what we'd call today a supernova explosion. So a very massive star at the end of its life runs out of nuclear fuel. And as I said, we now know nothing can stop the collapse. So it collapses, they bounce to some extent, which release a huge amount of energy, glow very brightly, as bright as a galaxy in some sense, for a few weeks, and then collapse without limit. And what they leave behind, of course, is a black hole. Now the key point about the Einsteinian description of a black hole in this equation is that it's as if the star's been removed from the universe, but its imprint, the distortion in the fabric of the universe, is still there. It just really is almost as if the star's just been taken away. And the reason that is interesting and gets strange is this clock. So remember I had this clock and I'd sat it on the face of the star because you can't go any further in because there's a star in the way. But now the star's gone, but the equation is still correct, that space is still there, it's just more and more distorted. So I can move this clock further in. So I can go into 100,000 kilometres or 50,000 kilometres, or, I mean, really, there's nothing to stop me putting this clock at 3 kilometres in, if this is a black hole the mass of the sun. 3 kilometres. Well, now you see what bothered everybody, because look at this equation now. This is now 1 minus 1, which is 0. So the prediction from Schwarzschild and Einstein is that if a star can behave like that, if it collapses without limit, then there's a place in space there where time stops. A place in space, that's 0. A place in space where time stops. So that seems absurd, as Eddington said. What does it mean to have a place just there?